Deloitte's AI Forum 2025 India. In real time, transforming with AI.
Good afternoon. It's my honor and privilege to welcome you, Vishal. I don't think Vishal needs an introduction. He's one of the most recognized faces in the world of AI in India. I think he's ranked among the top 9 AI influencers by the Data Analytics magazine. And one person who has evangelized the AI use cases in every aspects of our economy, whether it's government, enterprise, and someone who has been at the forefront of adoption of AI in India and the entire NVIDIA journey. You've seen it very closely. So welcome to this session with this is a fireside chat with Vishal.
Thank you, Devesh.
Vishal, I think let's first address the elephant in the room. We've been from the first session onwards. We've been hearing about DeepSeek. Yeah. So DeepSeek, they say week is a long time in history of certain aspects. So what's your take on DeepSeek? Because that's completely, divided the industry. It was moving in certain direction, and suddenly the DeepSeek came. Because first what came was Trump's grand announcement about Stargate, and that really had caught everybody's attention. And suddenly the Chinese came with the DeepSeek. So what's your take on that?
Looks like after Transformer got introduced in 2017, attention is the most used word. But what a beautiful period of time. Isn't it truly, truly exciting? 2012, big bang of AI. A problem statement which has been upon us. How do we solve the problem of perception? Computer vision people have been trying for years and years. And on one fine day, deep neural networks, thanks to the work of Jeffrey Hinton, Alex Krasnowski, they discover a gaming GPU. And out comes this result which is tremendously different. And even people like us who were in this business trying to solve the computer vision problem stood up and said, what really happened? However, we reasoned with that if there is a deep neural network that works on a GPU, on your and my data that we call digital experience, what is its implication? How far can it go? What can it do? And the answer was pretty simple, that this is a God-given opportunity. We got to embrace it. It seems no limitations currently. Unless your assumptions are totally wrong, there's nothing wrong unless laws of physics come into play and other elements come into play. So from 2012, great work happened, lots of good stuff happened, and we learned to overcome some of the challenges that were associated. The introduction of Transformer brought in another excitement. Not only did it teach us how to understand the meaning, the representation of the underlying data, but it also allowed us to move from one modality to the other modality and exchange the meanings from one place to the other. Imagine that you can now understand a structure of amino acid and you can talk the language of protein so that you and I can stay healthy. That's the determination that took place. Models were getting built fundamentally because it came to our conclusion, the bigger your model, it's like having an Einstein mind and you giving him more and more inputs so that you can have Einstein outputs. So the bigger the brain, the bigger the inputs, the better the model, the more the inputs. That became a mechanism by which models were getting created. What did DeepSeek show? There was one side of the world where there was abundance of resources and we did it. The DeepSeek showed us that how do you do things in a constrained manner. And these two things are just wonderful example for science. So 10 years to 12 years has been all about science, what the science needs to do at a fundamental level, I believe now we stand at a junction where it's application of the science. So we're moving from fundamental science to the application of the science. We're talking about use cases, and it's all upon us. How do we benefit from this tectonic shift, this seismic shift that has taken place where we used to write software hand-coded. Now the machines help us to write the software. So the software is writing the software. And that's the way you should look at it.
No, it's absolutely. It's like really one of those fundamental changes that we have probably seen in last many 100 years. It's almost on the scale of electricity or internet. And when interestingly, I've been in the energy sector. One of the things is when electricity was invented, first came DC, which is Thomas Edison came with it. When the AC electricity came by Nikola Tesla, Edison wanted to prove him wrong by electrocuting mice all over New York to say that it's more dangerous. So, but it's so fundamental that it changed everything, the use cases of electricity. Similarly, I think GenAI will change the industry after industry. Like you mentioned, I think from drug discovery, molecules would take probably 7-8 years. Now it'll probably happen probably 1/10 of the time. So it's a fundamental change. But coming back to NVIDIA, from a GPU supplying to the gaming industry, how has been this journey? And now this entire change of NVIDIA's presence in across the value chain, it's been quite a staggering. And suddenly, probably last 3-4 years when the stock market discovered, probably a lot of people caught the trend, but it was like it was a staggering kind of a arrival in the scene kind of a thing. How do you see that journey?
I see Sundar sitting here, smiling. He's only been taught, don't worry about the scorecard, just think about the game plan. There have been days when the stock market makes you a better recall. There are days when it doesn't, but that's not what it is. 1993 is when NVIDIA got established. The observation that was made at that time, that if you look at the software code, 90% plus code is serial. You write software on a CPU in a sequential way, and it does a wonderful job, but there is approximately 8 to 10% of the code that occupies 90% of the computation. Now, wouldn't it be just wonderful if there were two processors, one dealing with parallel compute, the other with sequential compute? If that was to happen, that would be the most optimum way to build a computer. Question was, what were the applications? And one of the core applications was computer graphics. And in computer graphics, when you form companies, and I know that there are a few startups here who typically think about building companies which are long-term. Some believe that let's form a company and translate that into monetary gains and move out. But our belief was that let's build a company for long-term. If we build a company for long-term, always find a problem statement which will take years to do. And for computer graphics to come closer to real world is a lifelong problem. And that's why our domain was computer graphics. Now, the larger question was, just because you have a big problem, what is a way that you're going to find a killer application? And that killer application was gaming. Why was it gaming? Because PCs are used by humans who work. And after using the computer when they go home, they play. So if I want a human to work and play, I should bring gaming to the PC. And to solve that problem, to make sure that people from the consoles can come to the PC, or we can bring console into the PC, you got to do it differently. That is to quickly solve problems which reduces the gap between the virtual world and the real world. So in net effect, the company was always established to solve hard computing problems that general purpose compute, which is built around CPU, could not solve. We solve problems in computer graphics. We spoke about computer vision. In 2012, GPU discovered AI. In 2024, AI is discovering the GPU, and the story just continues, solving one problem after the other problem, because none of you in this room, because I can almost guesstimate that all of you who are here have ever experienced any other computing fabric but the general purpose computing fabric. And this was actually introduced in year 1964 by IBM, because IBM came to this observation that the software has the value, and with every change of architecture, you should retain the value of the software. It got scaled during the PC revolution, what many people refer to as Moore's law. Every 2 years, you would reduce the cost of doing the same software by half. In other words, you had deflation allowing you to bring in more and more applications. And today, from 2012 onwards, it's been crystal clear that now is an opportunity to use scaling laws of a different level and bring intelligence, manufacture intelligence, and make our lives that much more productive.
It's much beyond now Moore's law in terms of the acceleration of the compute power and the cost reduction that we have seen in recent times. And as you articulated, I mean, NVIDIA is much more than just the GPU. You have your own stack around CUDA, around the foundation models, networking, storage, the whole lot of things which you offer to the client. So what's the advantage of having that entire range of things rather than just supplying the chip?
Right. But let me just step before that. So at the current moment, there are 3 scaling laws which are upon us. And the first scaling law, which is the pre-training part, which benefited the large language model, is a simple concept. The more you provide, the better is the result. And that continues to scale. The second scaling law, which is upon us, is that how do you ground it? Everybody spoke about when ChatGPT came, oh, it hallucinates, it's biased. But when you ground it with your own knowledge, what exists inside your organization, what makes you unique as a society, as a country, then the ground truth starts coming into play, and that's the second scaling law. The third one is the test time scaling law, that when you put it into implementation and everybody's using it, in what manner do you use? All these are compute requirements. And the way the compute was built up till 2015-16 was for sequential computing. It was in 2016 that NVIDIA realized that we'll have to change every single layer of computing. And they created a computer that is very well known among the practitioners called the DGX. The DGX was created for our own engineers. And it was also gifted to people who are in leading edge of research. So Jensen walked up in 2016 to Elon Musk at OpenAI and gave him the DGX. He gave that to Andrew Ang, and he gave it to several other researchers. But we started our journey. We started our journey saying that how do we look at problem statements and make our engineers work towards it? There were 2 problems, again, inspired by humans. Safe human and a healthy human. A safe human who someday, sitting in a car, coming into JW Marriott to speak to Debasish, does not have to worry where my clutch, where my brake is. I can comfortably talk to my colleagues, understand what's happening, the car drives me, and I come here safely. The second one was that if I can really understand why does the human cell malfunction, if I can predict it, and if I can find a solution to it, I'll have a healthy human. If a healthy and a safe human is in play, became the vision of our company, they needed tools to do this. And the tool that was built was the DGX. for the very first time in the history of computing, you had more GPUs talking to each other that outlived the number of CPUs into it. We reformed the algorithms, we reformed the networking, we reformed all of them, and we learned what it takes on the scale. And then, once we build this, we would dismantle them. We would dismantle them because the previewers of our technology would take them into their data centers, into their servers, into their computing need, and with their brand, put those parts there. And that's why we build, we dismantle, we enable, and we allow the world to prosper.
No, this is really fundamental, as Jensen says, something very fundamentally is changing in both in compute and the tech stack. Where do you see India here? I mean, we have been at the front end of technological adoption with our tech stack and our digital public infra and all that. Where do you see India adapting? Because you've been part of a lot of this AI mission and you've been advising states like Telangana. You're an advisor to MIT. Where do you see India adapting to both in terms of the compute and the tech?
So India has a fundamental advantage. India has the software engineers, the industry rises from here. We know what services are. And I think it was skill-based services that we provided. Today, we have machines that machine learning is upon us. It's a different kind of computing. We want our skills to understand the machine learning part. And I think the opportunity, India is right in front of us. In 2018, there was a strategy paper published by the gentleman who was here in the morning, Mr. Amitabh Kant. And the strategy paper was AI for all. It was to make India the garage of the world. He also invited Jensen at that time to interact with the Prime Minister, with the entire cabinet, and all the bureaucrats that used to work in New Delhi at that time. There were about 1,500 of them. And the idea was to demystify AI and help India leapfrog on it. Our journey really began from there. And then in 2023, after COVID, we did a little bit of a dipstick check. And to the credit of Jensen and to the credit of the Prime Minister, Jensen made a statement that India is doing really well, both on the physical infrastructure as well into the digital transformation. But if they're lagging, we are lagging on the AI infrastructure. There is a need for India to be sovereign. You have the skill sets, you are historically a 5,000-year-old culture, your common sense, your sensibilities are unique. You have to encode that, and we need an infrastructure. Most importantly, our nation has been built with 0.5% of the population that spoke the computer language, making us prosper, looking good the way we did. But what if we brought 100% of the population that could work with the computer? That's an ability that's available today because you can speak in your language. Even with my very bad English and grammar, I can speak to computer today and computer can program. If we have to do that, this is opportunity India. So we have national initiative. Some of you probably read today that India AI mission is on. There are companies which have bid. It is under the public-private partnership where the capacities which have been built based on the same dialogue that took place with the Prime Minister over last year or so is now going to be available to the nation. The government is going to incentivize people to use it. And hopefully over the next few days, people will have capacities that are available. So just like, Bangalore is an interesting topic. I came into Bangalore in '84. I never used to think there was a need for dividers ever. Now I think there's a divider every inch telling me to only stay in my lane. Same thing, we brought in the infrastructure, we brought in the practices, the government is ready to subsidize it. We want people to now start translating their ideas into reality. And I'm quite certain the government will inspire. But most importantly, you live in a nation where there are challenges and challenges which are giant. Think about solving this problem at a giant level. Think big and come and let's solve this problem together. And we will find solutions, just like how we found a solution for transactions. I think the gentleman, I think it was in Sundar's panel, you spoke about UPI and the trust. It happened. We now can be identified with unique numbers. We now know how to get our tax income. Let's think about big problems. Let's come and solve those problems. I think in India, let's get going. Everything is in play.
One of the things Mr. Amitabh Kant, in his opening remark, lamented about is the Biden administration's last executive order, categorizing India in the second category, which puts a restriction on how much access to GPUs we can have. So how do you think that getting played out? Do you think that Trump administration will change that, or do you think that that will put a limit on, really the AI journey that India will have?
Just like you, I can only speculate. Unfortunately, I can't put my hand on his shoulders to ask him that question. But the truth is this. The diffusion regulation comes into effect on 15th of May. The diffusion regulation puts India amongst tier 2, which is 150 other countries. And it restricts the number of computers that can, or the GPUs that can come into any nation. It also restricts nations on the kind of models that you can use. And once again, India, in addition to the opportunity, has a challenge in front of it. And I do know, having grown in this nation, that we know how to work against challenges and do things that become envy of the world. So this is our opportunity. Let's take advantage of what it is. Let's not just do commentary. There are people in our government, there are people who are interested. They will continue to help us out. And I'm quite certain, if our work speaks well, if we can be the world which exports intelligence from this country, I'm quite certain there's going to be no constraint.
Day before yesterday, Romal and I, we were in Orissa, in that Invest Orissa event with Minister Ashwini Vaishnav, and he assured that within months we'll get to hear about the India LLM. So that will be an exciting thing to wait for. And I think in the previous panel, they were talking about mostly the agentic AI. But here we have a lot of clients who have come from corporate India. So two things about the enterprise side of the AI journey. First, I will ask you about on the compute side, on the data side. So, all the enterprise now will be looking at what will be the strategy around, whether it is cloud, whether it's a hybrid cloud, whether data in-premise, now whether to have their own GPUs, buy a few stacks. What's your take? That will be an interesting journey, because that also will drive the kind of cost it's going to cost, because a lot of bank CEOs have told us that, like cloud, the uncertain part of the cost element, it becomes they don't understand it. So what they have told is that they are pretty skeptical about the cost of AI that's going to hit them. So one element is very sensitive element is this, that what should be their data and the compute strategy.
I think he actually referred it pretty well. I would like every single leader, in whichever form, to firstly understand the data pipeline. We got to understand data, and you did a pretty good job on that, so don't want to take away what you stated, but it is so critical that if we understand as a leader what is data, what is it supposed to do, how do you munch it, how do you curate it, how do you blend it, what are we trying to achieve. Then there are many people in the company who know the strategy. There are so many think tanks who will tell you what needs to be done. So absolutely critical that as a leader, we got to understand what is this pipeline of artificial intelligence. And it starts on the data pipelines. Second thing, it is absolutely critical that to understand AI was born in the cloud. And native AI is going to bring a lot of glory, but we also have to take traditional applications into AI. And that's what we need to understand, how we're going to be making those changes. Then comes the third element, which is what you're asking about, the cost. It's not too difficult to work out on the cost. And therefore, it's upon us that let's stop thinking about data centers, which were storage warehouses. Let's start thinking about AI factories. Just like in the age of manufacturing, factories generate revenue, AI factories generate revenue. You take your and my digital experience, what people call data, you put that data onto an algorithm, outcomes, floating point, tokens, intelligence that can be infused. If you own the AI factory, you own the IP to that usage. It keeps you unique. Whether you are a bank, whether you are a large conglomerate, you function differently. And I think the easiest way, at least I try and understand it, look, all of us went to different schools. We went to different schools, but they were all set on curriculum. And within our approaches, we decided what we wanted to do. We prospered based on our talent. But when we went for employment, despite doing colleges, we were put into organization to learn the language of that organization. I'll give you an example. NVIDIA basically looks at marketing very differently. So we get a lot of these people, you tell them that we need to do a marketing blitz. The first statement they'll make is, give me dollars, I can do it. Sorry, I don't have dollars, but I still want to do a marketing blitz. They say, no, in my experience, unless you have money, you can't do it. And then you have to tell them, but in my experience, I've done these without money. And that amalgamation takes people some time. So not only is the fresh people, it's also the lateral hires which come to learn what your organization stands, and then you apply your experience in the context of the organization. It's exactly the same there. So as we continue to learn the context, as we continue to apply the uniqueness of the society that we live in, that's the differentiation. And that's why you require what the minister is saying, our own sovereign LLM. By the way, that's the beginning of the story. You will require sovereign LLM, you'll require domain LLMs, you'll require your company's LLMs, you'll require many more tools and techniques, and you will basically say that, hey, LLMs help generative AI to give you new content. Because of that, now you're moving into a world of agents where you can perceive, you can review, you can plan, you can act. And that's why agents are being spoken about. And then very quickly, you'll move into physical AI, where the AI will be grounded on physics. That's why robots will work. That's why 3D worlds will get created. That's where the economy will get created. All of us get really worried, oh, the world's GDP is 100 trillion. And you assume that it'll going to remain 100 trillion. Or even if it moves, it'll move by an inch or so. But, humans created 100 trillion. Humans will create multi-100 trillion markets. There's an opportunity for everyone because with intelligence, all of us will become productive. What I would really love is India to be called the capital of intelligence. In fact, Bangalore should be the capital of intelligence, just like how Milan is called the fashion capital. come, it's our opportunity. Let's start working on it. We can sit here, we can debate, we can keep giving commentaries. Let's get into it.
Thank you very much for the fascinating discussion. Thank you.
Deloitte's AI Forum 2025 India. In real time, transforming with AI.